Hello, everybody. So we are going to be taking a look at division today. How do you divide polynomials? And of course, what is it useful for? Later on in days to come, you'll see why we need this process. But today we're just going to focus on what it looks like to actually do polynomial division using a process called synthetic division. You're going to need your notes, pen and pencil, maybe a calculator to assist you in some of these calculations. So let's look at division in general. Remember way back in elementary school when we first started talking about division, and you had 200 divided by 12, and we'd say, how many groups of 12 can you make out of 200? And you may have set it up in this sort of long division fashion, and you may have done something like this. Well, how many times does 12 go into 20? One time. 12 times 1 is 12. That leaves me with 8 left over. Drop down the 0. How many times does 12 go into 80? 6 times. That's 72 with 8 left over again. So 8 is the remainder. After we do the division, there's going to be 8 left over that's not quite enough to make a group of 12. So you may have called this the remainder as a younger student, because it's what was left over after the division was done. The remainder we could write like this in younger grades, remainder 8, like that. But then later we kind of graduated to understand what remainders represent and how we can rewrite these remainders as fractions. So we probably rewrote it as, instead of R8, remainder 8, 8 out of 12, because 12 is what we were dividing by, 8 out of 12 left over, and we of course would have simplified that, dividing both by 4. We'd say, well, the answer is 16 and 2/3, or 16.6 repeating. However we were learning those things at the time in those earlier grades, whatever the focus was. So this look at division in the earlier grades kind of sets us up for what we're about to do now. So our goal today is to divide polynomials, not just numbers. So our look today will be dividing big long polynomials here, quadratic divided by x plus 1, the divisor. And we're going to do this using a process called synthetic division. So this part I need you to get in your notes. Synthetic division is an abbreviated form of long division, so it's a little bit faster, that we can do if we're dividing by x plus or minus some number. So we need to be dividing by x plus 2, x minus 3, x plus 4, whatever it is there, we can set up what's called synthetic division. Now what regular long division looks like, we divide out a polynomial, this is what it would look like, same setup. You have the whole polynomial on the inside like this, and then this is the divisor, what we're dividing by out there. Synthetic division setup, this is the process that we're going to be using. We've used synthetic setup before. We've done it with substitution. And so now we figure out what the rest of that process is. Notice the setup again. We have the 1, 3, and the 5. Those are the coefficients in my polynomial here. 1, 3, and 5. And notice here on the outside is a negative 1. Not a positive one, because in synthetic division, we divide out the solution, or the 0, to the divisor, and not what it says there. So not x plus 1. Okay, x plus 1 means that we're actually going to divide and put a negative 1 on the outside using synthetic division, because negative 1 would be the solution to x plus 1. Okay, so this sort of setup we're going to be using to do division. So this is the first example we need to get in our notes. We're going to do a few examples here. It's pretty straightforward. 3 examples, then we're done. So we're going to divide that polynomial by x plus 1. This is the one that I had set up in your notes. Go ahead and write this one down. Again, here's our setup. We're going to put the negative 1 on the outside because we're dividing by x plus 1. That means my solution is a negative 1, so I'm going to use the negative 1 on the outside there. And then the 1, 3, and the 5, remember, come from the coefficients in the polynomial here. And using our synthetic process, remember, we drop down the 1. Negative 1 times 1 is negative 1. We add 2. Negative 1 times 2 makes negative 2. We add 3. Here is what we get down here underneath this line. These things represent something. This guy right here, we used to circle and say I'm done. This is the value of the polynomial if I plugged in negative 1. But you should also know that this right here represents the remainder of my division problem. So just like that R8 we did in that little warm-up of remembering how division works, this is the remainder. So that means that all of these things here represent parts of a polynomial. When you divide a polynomial by a polynomial, you should get a polynomial. So we need to rewrite our answer here in polynomial form. This is a remainder. In front of the remainder is going to be a regular number or a constant. In front of the constant is always going to be an x in standard form. So when we rewrite what this answer here represents, what polynomial do I get when I divide something by something else? I can rewrite it saying I have 1x plus the number 2 plus the remainder of 3 over, now this is where we go back to our earlier grades, understanding that remainders can be written as fractions of the divisor. So 3 over the divisor x plus 1, because that's what I was dividing by. So this polynomial that we get here, guys, is what my answer would be, my quotient plus my remainder, that I would get if I divided the given polynomial by that little polynomial there. Okay? So this is what those other numbers in that process represent in that whole synthetic substitution or division, in this case, setup. So let's look at a second example here. We're going to go ahead and set it up. We set up our synthetic. The numbers in the problem, I have a 1x to the 4th. I have no x to the 3rd, so I'm going to put a 0 there. Negative 10x squared, 2 x's, 3 for regular number there. And I'm dividing by x minus 3. That means I'm going to put a positive 3, the solution, to that guy out there. And now we're going to go ahead and divide this out. So 3 times 1 is 3, add. 3 times 3 is 9, add. 3 times negative 1 is negative 3, add. 3 times negative 1 is negative 3, woo, add. 0. 0, happy face, I have a 0 remainder. That means my answer is not going to have that funny fraction at the end. In front of the remainder, this number represents the plain number in my polynomial, or the constant. This number represents the x's. In front of x's, in standard form, would be x squareds. And in front of x squareds would be x to the 3rds. So my final answer for my polynomial here is I would have 1x to the 3rd plus 3x squareds minus 1x minus 1, and I don't have to worry about any remainder. So this is my quotient there, my answer to my division problem. Okay? Let's do a third example. This is the last one. This one's written a little differently. Remember, fractions are just another way to write division. So I have a polynomial divided by another polynomial. Who cares if the problem's written differently? We still go about dividing the same way. So this guy right here, I'm going to stick inside the box here. 1, negative 2, 3, negative 4. This is my divisor, so I'm going to solve him or find the solution to him. The number 2 would go on the outside, positive 2. 1 gets dropped down, and I'm going to do the dividing process here. 2 times 1 is 2. Add 0. Multiply 0. Add 3. Multiply 6. Add 2. So my answer here, I need to rewrite what this represents. This is the remainder. This is the plain number. In front of that would be x's. In front of that would be x squareds according to standard form. So my final answer would be 1x squared. I don't have to write any x's because I don't have any. Plus the regular number 3, so constant 3, plus the remainder of 2 over my divisor was x minus 2. So my quotient plus remainder, polynomial, there you go. Okay, so this is what division looks like. We're going to be using this process to help us find solutions and understand what's going on here with these polynomials as they get a little bit more complicated later in the week. Okay, thanks.